Something strange is happening in our oceans. While global temperatures keep rising, one icy patch refuses to melt. Scientists are calling it the Cold Blob. It defies all predictions. It shouldn't exist, but yet it does. Its presence hits at something far more significant and far more dangerous.
When you cross a tipping point, you self-amplify warming, and the warming leads to even more extreme events.
This might be the first warning of a system collapse deep beneath the waves, a collapse that could shake the entire planet. Today, we uncover the truth about Earth's hidden heat engine, the AMOC. What happens if it fails? How close are we to the tipping point? Well, let's find out. Deep below the surface of the Atlantic Ocean, a giant system is always at work. It moves water across the planet like a slow but powerful conveyor belt. Scientists call it the Atlantic Meridional Overturning Circulation, or simply the AMOC. This flow carries warm, salty water from the tropics up to the North Atlantic. When it reaches colder regions, the water cools, sinks, and travels back south beneath the surface. This cycle is not just about moving water, it moves heat. It keeps Europe warmer than it should be, keeps tropical regions from overheating, and helps balance weather patterns all over the world. Without the AMOC, winters in Europe would feel like Siberia. Storms would rage in places that are now calm, rainfall would shift, and billions of lives would be affected. What makes the AMOC even more fascinating is its delicate balance. It depends on temperature and salt. If one part changes too much, the whole system slows down, and if it slows too much, it could stop altogether. In the middle of the North Atlantic, there is a strange icy patch of water, and scientists have named it the Cold Blob. It sits like a silent warning in an ocean that is otherwise heating fast. What makes it even stranger is that climate models never predicted it. According to those models, it simply should not be there, but yet it is. And that has experts deeply concerned. Now, the Cold Blob could be more than just a random cold spot. It might be the first sign that the AMOC is slowing down. Ice from Greenland is melting fast, pouring fresh water into the Atlantic. This fresh water makes the ocean less salty, and less salt means the water doesn't sink as it should. Now, without sinking, the AMOC weakens, and if this process continues, the entire system could break down much faster than we thought. The AMOC is not just a flow of water, it's the heartbeat of our climate. When it runs strong, weather patterns stay steady, rainfall's where it's needed, crops grow, seasons follow their usual path. However, when the AMOC weakens, the balance begins to break. One of the biggest concerns is rainfall. The AMOC controls the position of the tropical rain belts, which feed the mighty monsoons that over half the world depends on. Countries like India, China, and many parts of Africa rely on these rains for farming and drinking water. Without them, droughts could spread, crops could fail, and food shortages would follow. As the AMOC slows, the northern hemisphere cools and the tropical rains shift further south. Entire regions that count on seasonal rains could be left dry. Scientists fear that billions of people could be affected, with their food and water supplies at risk. Now, the danger doesn't stop there. Storms could become stronger and weather patterns could become unpredictable. The ripple effect of a weak AMOC would be felt across every continent, changing lives in ways we are only beginning to understand. Scientists have been watching the AMOC closely. Some believe it's already slowing down. In fact, several studies suggest the current could weaken by as much as 46 to 55% by the end of this century, depending on how much greenhouse gas we emit. Some models even warn of a complete collapse by mid-century, which is only a few decades away. But not everyone agrees. Some experts say there is not enough clear evidence yet. The problem is that the AMOC is hard to study. It moves slowly and changes naturally from year to year. We've only been measuring it directly for about 20 years, which is actually a very short time in Earth's history. What we do know is that there has been a slight slowdown in the last couple of decades. However, this change is difficult to confirm because the AMOC is so complex. It could just be nature's ups and downs, or it could be the early signs of something much bigger. To get a better answer, scientists are looking beyond modern tools. They're turning to the past, digging deep into the history of Earth's climate. By studying ancient records, they hope to find out if the AMOC has slowed before and what happened when it did. Since our modern measurements cover only a tiny slice of time, scientists search for answers buried deep in the past. They're studying layers of ice, mud, and stone to understand how Earth's climate behaved long before humans kept records. This field is called Paleoclimate Science. In places like Greenland, scientists drill deep into ice sheets. Each layer of ice holds tiny bubbles of ancient air, locked away for thousands of years. By melting these samples and studying the gases inside, they can learn how warm or cold the Earth was and how much methane filled the atmosphere. Now, methane matters because it's linked to the strength of the AMOC. When the AMOC is strong, monsoons grow more substantial and wetlands in tropical regions produce more methane. But when the AMOC slows or collapses, those rains disappear and methane levels drop. Now, scientists also are studying caves. Stalagmites grow slowly from dripping water and hold chemical clues about past rainfall. They can see sudden shifts in the climate hidden in these stone records. From these studies, we know that during the last ice age, the AMOC collapsed at least 25 times. Each time it triggered massive climate swings. Now, these collapses happened roughly every 5,000 years, and the last one happened about 12,000 years ago. To understand what might happen next, scientists look beyond the Ice Age. Now, they studied the last interglacial period about 128,000 years ago. Back then, Earth was a little warmer than it is now. Greenland's ice was melting just like today with rising sea levels. What they found is both fascinating yet alarming. During that time, the Cold Blob also appeared in the North Atlantic. Mohammed Azat and his team discovered this by studying layers of ocean sediment. These layers showed signs of cooler water and lower salt levels, just like the Cold Blob today. The AMOC slowed down the dock then, but did not entirely collapse. However, the planet was not as warm as expecting it to become. If we continue on our current path, global temperatures could rise even higher by the end of this century. This is the warning from history. A slight warming slowed the AMOC before. More warming like we're now causing could push it past the point of no return. These ancient clues are telling us that the AMOC is sensitive, and we're testing its limits right now. Right now, our future depends on our choices. If greenhouse gas emissions continue to rise, scientists warn that global temperatures could increase by around 3 degrees Celsius by the end of this century. That would be even warmer than the last interglacial period, and that would be even warmer than the last interglacial period, and that extra heat would melt even more ice from Greenland. More meltwater means more fresh water flowing into the North Atlantic. This fresh water weakens the salty flow that drives the AMOC. If this continues, the current could slow down much faster or even collapse entirely. Most scientists agree that some slowing of the AMOC is almost certain. The big question is, how much and how fast? If it slows gradually, the damage might be manageable, but if it reaches a tipping point, the collapse could happen suddenly within just a few decades. That would unleash a wave of unpredictable changes. Cold winters in Europe, shifting rainfall patterns, and disrupted food supplies across continents. Time is running out, but the story's not finished yet. What happens next will depend on how fast we act to slow global warming. Even though the risks are real, there's still hope. If we manage to slow global warming, we can slow the melting of Greenland's ice. That means less fresh water flooding the North Atlantic and less pressure on the AMOC. The good news is that if the AMOC only slows, it might recover within a few decades. But if it entirely collapses, it could stay off for hundreds or even thousands of years. That is the future we want to avoid at all costs. So the solution lies in cutting carbon emissions worldwide, switching to clean energy, protecting forests, and changing how we use resources can make a real difference. Every step counts. The faster we act, the better our chances of keeping the AMOC alive and avoid the most dangerous impacts of climate change. The AMOC is a hidden force that shapes our world every day. It keeps our climate in balance, our seasons steady, and our crops growing, but now it stands at a dangerous crossroads. History warns us of its sensitivity, and science shows us the risks ahead. So what we do next depends on the future of the AMOC and billions of people. Lowering carbon emissions is not just about cleaner air, it's about protecting the very systems that make life possible. So what do you think? Is the AMOC heading towards collapsing? What solutions do you believe could save it? Share your thoughts in the comments below and let's keep this conversation going. Don't forget to like, share and subscribe for more stories that uncover the hidden forces shaping our planet.